This next diagram here of geometry, Euclidean geometry, involves parallelograms and fun angles, also involving some isosceles triangles. Looking at the triangle on the right hand side, we can clearly see that it's marked that EC is equal to CD. This would mean that E2 is 70 degrees, equal angles opposite equal sides. Next thing we're going to focus in on C1 and see if you can figure out what C1 is. Pause the video and try and figure out how much is C1. C1 is equal to E2 is equal to 70 degrees, alternate angles. AD is parallel to BC. The arrows mean that the lines are parallel. We are trying to prove that the diagram on the right hand side of the combined figure is a parm. In other words, we are trying to prove that ABCE is a parm. We can see that A1 is now equal to C1 because they are both 70. We can now calculate E1. We can see E1 is equal to 180 minus the 70 degrees, which was E2. So if we subtract E2 from 180 angles on a straight line, we can now find E1. E1 will be equal to 110 angles on a straight line. If we look at the diagram, what angles are those? Angle A and B. Angle A and B is equal to 180 degrees because they're co-interior. So if A and B collectively equals 180 degrees, we can then say 180 minus 70 will give us 110. So B is equal to 110, co-interior angles. Therefore, ABCE is a parm. Opposite angles of the parm are equal. Okay, so remember that once we prove the opposite angles of any four-sided shape of a quad are equal, that would mean that the quad is a parm. So therefore, the opposite angles of a parm are equal. So this would make ABCE a parm. Hope that made sense. Practice these. Have fun. Find angles.